Hi, welcome to this lesson on Analytical Geometry, Circles Part 1. Let's have a look at question 3. We're given the point P, negative 2, 3, lies on a circle with center, origin. Determine the equation of the circle. So since we know the center is the origin, by default, the equation of the circle is going to be x squared plus y squared equals r squared. Okay, so I've got a point for x and a point for y. So all I'm looking for is my radius. So if I substitute x as negative 2, and my y value is 3, this will be the value of r squared. Okay, so now negative 2 squared is positive 4, 3 squared is positive 9 equals r squared. So therefore r squared is equal to 13. So technically your radius would be positive root 13, and your equation of your circle will be x squared plus y squared equals r squared, but r squared is the radius, which is 13. So that is the equation of the circle. Okay, next we want to sketch the circle and label the point P. So again, the circle will have the center at the origin, and there's your origin point there, and the point P, so your x value is negative and your y value is positive, so that is the second quadrant. So when x is negative 2, y is positive 3, so there's the point P there, negative 2, 3. And if you were to construct the radius line from the origin to there, that would be root 13 as your radius. Okay. Next, if PQ is the diameter of the circle, determine the coordinates of Q. So if I come back to here now, here's P, and they're telling us that PQ is the diameter. So where do I put the point Q? Can I put it over here? Can I put it over here? Well, no, because if I put P there, then I'm going to get that line, or I'm going to get that line. Those are not diameters. So where would I need to put this line here? Well, again, if I think about it, so let me just get my circle back up here. Okay, so let's draw it over here this time. Okay, so again, it's going through the origin, that's the center. The point P was up here, negative 2, 3. And again, if I want to put this point Q now, it would make sense to find the mirror image. So if I go to the origin and then go out there again, that point Q there would make sense. Okay, that would be a diameter. And we saw that there was a nice symmetry with the circles. Okay, so the symmetry was, let me just write this more neatly here. Okay, I'm just going to undo that again. Okay, so I just want to try and write this part. Nope, it is getting rid of the whole circle, unfortunately. So let's just come back here. This was the point P, negative 2, 3. Okay, and then the circle is going through that point there. All right, so to find the point Q, I would just use mirror symmetry. Okay, so I would see that this negative 2 here would have to be a positive 2, and then this 3 would have to be a negative 3. So how was I able to do that? Well, think about this. PQ is a diameter. So that means the straight line here has a midpoint. That midpoint is the center, which is 0, 0. So I could use, if I wanted to, midpoint formula, but I'm going to use the geometrical interpretation of the midpoint formula, which just means that if however much I go down and however much I go right here is the same amount I must go down and the same amount I must go right. So I've gone down 3 and I've moved across 2. So if I go down 3, from 0, 0, I get negative 3. And if I go across 2, from 0, I get positive 2. So that is a quick way you can determine the coordinates of mirror symmetry in a circle. Okay, and then that will be a diameter of the circle. Calculate the length of PQ. So again, the coordinate of P was negative 2, 3. And the coordinate of Q we said was 2, negative 3. So if I want to find the distance of those 2 points, I could either use the distance formula or I could just use the Pythagorean theorem. They are exactly the same. So I'll use the Pythagorean theorem and I'll ask myself, from negative 2 to positive 2, how much units did I go across? 4. And then from negative 3 up to positive 3, how many units did I go up? 6. So therefore I can say that PQ squared equals 4 squared plus 6 squared. That's going to give you 16 plus 36, which is 52, right? Yeah, 40 and 12, 52. So therefore, PQ, because it's a distance, a length, it's the positive square root of 52. 52 is 26 times 2. 26 is 13 times 2. So I get 13 times 4 is 52. So I can break that up. So it'll be 2 root 13 when I take the square roots inside. So it's 2 root 13 units long. Determine the equation of line PQ. Okay, so a lot of analytical geometry coming out of here. So again, in that Cartesian plane, if we're just looking at the points P and Q, which goes through the origin, okay, P was the point -2, 3, and this was the point 2, -3. So the equation of line PQ, we just need the gradients, and this will be equal to y mx, not mx plus c, because I know it goes to the origin. So c is going to be 0 anyway. So how do I work out the gradient? Again, it is rise over run. You've gone down 6 units, you've gone across 4 units, and because of its direction, it's sloping negatively, your gradient is -6 over 4, which reduces to -3 over 2. So therefore, the equation of line PQ is equal to -3 over 2x. Okay, and that is the equation of that straight line. Lastly, determine the equation of the line perpendicular to PQ passing through the point P. Okay, so again, we just need to visualize what's happening here. So on the xy axis, you've got your circle with the origin 0, 0. And you've got the point P, which is -2, 3. You've got the point Q, which is 2, -3. So you want equation of a line that's perpendicular to PQ. So here's the diameter PQ. So it must be perpendicular, first of all, and it must pass through the point P. So it's going to be a line that looks like this. Okay? So I need the equation of this line. I'm going to call it y perp for y perpendicular. Okay, so first of all, to find that, it's going to be of the form mx plus c, but I know something special when it comes to perpendicular lines. The gradient of this perpendicular line times the gradient of PQ must be -1, since these are perpendicular. But I know that the gradient of PQ, I worked that out just previously, it was -3 over 2 equals -1. So to solve for m perpendicular, I need to multiply both sides by 2 and then divide by -3. So it's going to be, on the right-hand side, 2 over 3. So that is the gradient of this perpendicular line in green here. So this is equal to 2/3 x plus c. Okay, and then I need a point, but I know P is the point that is common to both. So if I substitute the point P now, I get 3 equals 2 over 3 times -2 plus c. Therefore, I'm going to get, so this simplifies to -4 over 3, this right-hand side here. So I'm going to add 4 over 3 to both sides, and that'll give me the value of c. So therefore, c is equal to, well, 3 I can write as 9 over 3, right? So it's now a common denominator, so I get 13 over 3. So hence, the equation of this perpendicular line is given as 2/3 x plus 13 over 3. And based off we draw it, we can the way we drew it, we can see that the y-intercept makes sense to be a positive number there. And that number is bigger than 3 because here's 3 over here on the y-axis. Okay, so geometrically our answers are sound. Alright, so that's how we would do these types of questions. I'll see you in the next one.